All right, so we're going to go over some quick, easy tips on diagnosing a Dometic water heater, troubleshooting you through it, and figuring out what's possibly wrong with it. The only tool you're going to need for this is going to be a multimeter. If you don't have a multimeter on you and you're trying to diagnose this in a hurry, stick around to the end of the video. I'm going to show you a few tricks on how you can diagnose this without having a multimeter. It won't work for every type of diagnosis or every issue, but it will work for the most common ones. So we'll cover those at the end of this video. So for the multimeter, you're going to hear me refer to grounding something. If you're not familiar with that, you need to take your black lead, which your black lead is very likely going to look like this. I just happen to have a different adapter on mine so that I can just ground it to something. If you're looking for anything bare metal in here, I'm usually, with my clip, going to go to the base of the igniter, but you can go up here, you can go here, any one of these screws, pretty much anywhere that's metal inside of here. From there, you're going to switch your meter to read voltage and make sure you are reading DC voltage, which is indicated by the line with the dashes underneath it, whereas the squiggly line is AC volts. Your meter may be different and those options may be checked through here. Either way. So the very first test you're going to do, and you're going to notice my top plug is actually unplugged from my control board, and that's because this water heater has no issues and it works. And if I connect this with the switch on inside, it's going to try and light, and there's no water in it, so I don't want to do that. So the very first thing is you're going to want to check for your signal. So if I can get in the right one here, can't talk and think at the same time. So when you have it turned on and you're set to propane, you should have 12 volts on your, or at least 12 volts. More likely if you're plugged in, you're going to have something closer to like 13.5 going to that pin. That orange wire indicates that the board is in fact getting signal to ignite via propane. Whereas if you were trying to use electric, you should have power to the white wire. That tells you that your switch inside is working just fine and everything is fine and dandy. So in order for me to plug that back in, I'm going to disconnect that one. That will disable the starting sequence. So we're going to plug that back in. We know we have power coming into our orange wire, so our switch inside is working just fine. So this water heater is going to use a few safety features, and those are the few safety features that are very commonly going to fail. So on here, again with a perfect circuit, if I connect these, this water heater will light because nothing's wrong with it. Just like that. Right? So the way it's using these two circuits here, this is your ECO and your Tstat. Behind this little felt pad back here, you would see something that looks like this. And this is a temperature limit switch in layman's terms. The easiest way to explain this device is it's a breaker, but instead of tripping because of overcurrent or overvoltage, this is going to trip when the temperature gets too high and break the circuit. So what's happening is your board here is sending out a signal on this maroon wire, and it is coming back via this maroon wire, or vice versa, either way. If that doesn't have a complete loop and the signal does not make it all the way through that loop, in other words, if one of these is tripped and breaks the signal, it's going to tell the board that it's not safe to light because it's either over temp or something is wrong with that safety device. So how do you check these? Well, for one, I'm going to show you the most common problem with a Dometic water heater. Thermal limit fuse, rollout sensor. There's a lot of different things you may hear this called. This is the most common culprit for the water heater itself not working. So to test all of these components, I'm going to go back to using my black probe, and I've disconnected my alligator clip there. And you are going to check for continuity on these three things: the ECO, the Tstat, and then your thermal limit fuse. You're going to do that by switching to a little horseshoe, if that's what you want to call it, right? And you're going to do what's called a continuity test. You're going to make sure that power is capable of passing through all of these switches. So let's back up here a little bit, come down. Here we have the thermal limit fuse. This is the very first thing we're going to check because, again, it is the most common problem. That beep and it showing resistance tells me that this is just fine. If I were to connect these two like so and touch them to each end and I still got the OL or open or didn't get a beep, that's going to tell me that this is no good. So we know this is good. The next thing you're going to check is your ECO and your Tstat. And you're going to do that the very same way, only you're going to have to take the spade connectors off. So getting these off from time to time, they can be a real pain to come off. If you've got a set of needle nose pliers or even like a Gerber multi-tool, you should be able to get them off just fine, and they'll pull off like that. From there, you'll have two prongs, and what you're looking at is those two prongs there. So you're testing for continuity between these 2 points. And again, you're just going to take one lead on each side with your multimeter set to continuity like this, and what you're listening for is a beep if your meter is capable of that, or any form of resistance. So I know my microphone blocks out outside noise. I don't know if you can hear it, but that is beeping. So that one is good. You're going to do the same thing over here on your ECO to verify that you have continuity between there. Now, if I were to hook to here and had both leads on there and I was still reading that OL, open circuit, or not getting continuity, then I would know that that's my culprit. These are very easy to replace as well. This little sticky foam cover comes off, and these just kind of push in and twist out. Very easy to find part. Pretty much any RV dealership's going to have them, Amazon's going to have them, and that goes for your thermal limit fuse as well. Most of the time when you're searching for this, it's going to be labeled a thermal limit fuse. I know some of you furnace guys or anything like that might consider it like a rollout sensor or rollout fuse, because that's technically what it is. It's to detect flame rolling out from the burner into the case here, and in that case it would heat this fuse up, trip the circuit, disconnect the Tstat from the board, and the board would shut down the heating sequence. Okay, so in this video, I'm not going to cover too much of advanced diagnostics. Again, I cater my channel to mostly newbie RVers. So beyond this point, there are a few other things you can check. Is it something that you know the average DIYer is going to replace? Maybe not, but I will cover them nonetheless. So if your Tstat, ECO, thermal limit switch is good, the signal to the board is good, and you have good voltage coming to the board, there are a few other things you can consider. So if it's not lighting on gas and it is clicking, as in it's trying, but it's not lighting, you can verify that propane is blowing through here, or you could even check for voltage at these ports to make sure that the gas solenoids are getting proper power. The easiest way to really do that is while it's trying to light, you can check for power at the red wire here, because that red wire is the one sending signal to open the gas valves over here. So if you have power at the red wire and at your gas valves and no gas is coming out, you very likely have a bad gas valve. It's probably one of the least common culprits. Your three most common are your ECO, Tstat, and of course this thermal limit fuse. Now what happens if that circuit's good, all your thermal limit switches and everything are good, you have good power, you have good switch power, there is a fuse on the board right here. It's a little 2 amp fuse. I'm sure you can see underneath that plug there. Sometimes that can be tripped, also not very common. It's worth checking at least. But if you get to a point where there's no ignition, you could have a bad igniter wire. Again, that's getting into some more advanced diagnostics, kind of. It really depends on your skill set. I've seen a lot of people keep spares of these in the coach. It is a more common part to fail, but not nearly as common as an ECO, Tstat, or thermal limit switch. Anything after that, you could have a bad board. A bad board is usually diagnosed by good signal coming in, good power coming in, your circuits are good, your limit switches are good, but the board's just not doing anything. It's not trying to light, it's not doing any of that. You can test it that way. As a technician, we have board testers, or a lot of us will just have a known good board on hand. We'll slap that one in real quick, see if it lights, and we'll know it's a board. If you're really desperate to diagnose a board in the field and you don't really have the ways or means of testing it, find a camp neighbor, a friend, someone cool enough to let you borrow their board real quick. If they have a Dometic, it's the same board. So all you're going to do is take these two screws out and swap the boards. If yours lights, you have a bad board. Boards, again, they're not common enough for me to tell you to worry about that one. They do fail. It's just not as common as these other components. While we're in here, if you're just having lighting issues, make sure you check on your burner. Make sure it's free of any debris or any kind of nests or leaves or anything. And then make sure when it's trying to ignite and you can hear the clicking, that you can see a nice clean spark back there. Keep your hands away from this that entire time, because that will buzz the hell out of you. It's not very fun holding on to that or being near it when the water heater tries to light, because it is going to zap you. Now, as far as the electric side goes, these are all going to play a part in that as well. But what you're going to make sure is that the board is signaling and you're getting the proper signal. So the same way we check the orange wire when the gas was on, when you turn electric on, you should have at least 12 volts on your white wire. After that, if all of that is good here, it should be sending signal to the relay to turn the heating element on. That's off of the yellow wire. So you're going to shove your probe in there. Just give you a visual on that real quick. Your red is going to go into the yellow, and you're going to check for voltage there. And if you do have a good at least 12 volts coming out of that yellow wire, and you still have no electric hot water, I do recommend, if you're new at this, not getting into the AC side of things, but I will explain it at least. This cover comes off on the Dometics. On some other water heaters, it's on the back. This cover comes off, so what you're going to check for is voltage at the heating element. If the heating element is in fact getting voltage between the two screws, should be at least 110 volts AC. If you are getting voltage there and it's still not heating, then you have a bad element. You could also do a continuity test between the two prongs on the heating element, and you should be getting somewhere between like 11 and 14 ohms on a good heating element. If you're getting 0 or OL or something really low, then you very likely have a bad heating element. More issues are usually with the gas side, so I'm trying to focus there. Getting into the electric side, almost all water heaters are the same as far as checking your heating element, and there are already tons of videos on how to do that. Though if I see the need for it, I may just do a video on that particular part. So now, as promised, for those of you who want to do a quick, easy diagnostic on some of the common issues, but you don't have a multimeter, I'm going to show you how to do that. So you have your most common culprit here, which is the thermal limit fuse. When that breaks, it's going to break the signal and tell the water heater not to light. So if you want to check if this is bad without a multimeter, simply remove it from the circuit and reattach the spade connector directly to the Tstat, essentially bypassing this. If the water heater lights, this is your problem. If it doesn't, replace it and move on from there. So we'll get that back on there. So now you have your Tstat and your ECO. We're going to check those the very same way, essentially. We're going to bypass them. So you're going to remove both of these. Again, you may want to have a pair of pliers, because those little plastic spade connectors do not like to come off. So now you have these two things. This is all you're going to need. You're going to bypass that Tstat by simply placing these on the fuse. Now, quickly, just to show you that works, I'm going to connect my connector up here, and the water heater will light. again, there's no water in there, so I'm not going to leave it running. So that bypasses the Tstat. Now, 100% disclaimer, do not try and run your water heater like this. Not even for a short period of time, not even if you're watching it. That Tstat serves a purpose, and by bypassing it, you are going to let this water heater overheat and overheat quickly. You do not want to do that. This is strictly for diagnosing so that you can order this part, get it Amazon next day, get it replaced. Simply that. That is the only reason I'm showing you this, because I know some of you guys are new to the RV world. You haven't grabbed yourself a multimeter yet, and you still want to diagnose your water heater. So that is the only thing this is for. This will not trip if the water heater overheats. This will not prevent a fire. This will cause problems if you try and run your water heater with that. All right, now that we've gotten that out of the way, you're going to do the same thing for the ECO. Pull your two spade connectors off, place your fuse between them. If the problem goes away and it lights, you know you have that. Again, both of those things, they're usually in 2-packs. You'll find them like this, again, all over Amazon. You can get them at anywhere that sells RV parts. Very common part, and they're used across multiple types of water heaters. So as far as easy go-to troubleshooting, that's about as far as it gets. Again, we get into having board failures and things like that. There are, again, simple ways to diagnose that as far as just swapping the board with a known good one. Most places that sell you a board, it's non-returnable. So if it doesn't fix your problem, keep the board, because down the road you're very likely going to need it. The only things I would recommend having on your coach all the time, if you're worried about being stranded somewhere with no hot water or anything like that, would be to buy a pack of these. Very inexpensive. They come in a 2-pack. Same with the thermal limit fuses. They come in a 2-pack, also available on Amazon. And if your budget suits, keep a spare control board. You can get cheaper control boards from Dinosaur Electronics, remade boards. Keep a spare control board and try and do the same thing for your furnace parts. Your things like your sail switches and your ECO switches, igniter wires. Those are really good things to have spares of on board, especially if you're relying on this stuff. You're going to be out camping for longer than just a weekend or something like that, or you're going to be somewhere that doesn't have any of the things like showers or bathhouses at the campground. And again, another big important one that I'd like to make sure I cover, and I think I did already, was making sure that your burner tube is clean and making sure that your igniter has a nice clean spark. You can remove the screw over here and take the igniter off and clean it with a dollar bill. Dollar bill works a lot better than you think it would for cleaning igniter wires. You can also use a little piece of sandpaper, emery cloth. Hell, you can even use a nail file. I know a lot of you guys have one of those in your beauty bag. Yeah, outside of that, you're getting into some more complicated diagnostics if you have some more weird issues that just don't want to go away. So it may be time to get it into service if you're not that far along. But for you DIYers, that's pretty much your most common points of failure. If you're interested in seeing more videos like this, make sure you guys press that subscribe button. And if you guys have any specific video requests, I'm always willing to hear them. I'm all ears in the comments. For all of you guys who have been following me throughout the past year and getting TikTok blown up and then bringing it over here, and your continued support, again, I thank you guys. You guys have a great day.